All right, here we go. We're starting objective 6, and we are going to put together the idea of solving logarithm equations, but we're going to use the laws of logarithm, okay? The laws of logarithm that we learned on objective 5. We call it properties, but that's what we mean when we say laws of logarithms or properties of logarithms, okay? We're going to also remember that we have to use all the basic properties and rules of logarithms, okay? So if we have the logarithm with the same exact base on both sides of the equation, we call it, I'm not sure it's mathematically correct, but we call it, we drop the logs because they are exactly the same, and then we can compare those values of x equals y, and we can solve it for one or the other, okay? In exponential is the same thing. If the bases are the same on both sides, 2 to the 5th power equals 2 to the 5th power, then the x value, the exponent, has to be equal to the other exponent to be a true statement, okay? So we're going to have to keep the review, understand, and use it, the laws of logarithms, properties of logarithms, and there's 3 laws or properties we used in objective 5. So we need to recognize when things are expanded, okay, expanded, and we're going to have to condense it into one logarithm, condense, okay? So we have to recognize when I have too many logarithms, I need to condense, especially when I'm trying to solve equations, okay? So we are going to go ahead and do a quick review here, just a few, so it doesn't become super long video. Let's review some of these rules right here. It's asking me to simply evaluate. We always have to remember that evaluate is just finding an answer to a function. For example, evaluate the square root of 4. Well, I know it's 2, okay? Evaluate 2 cubed. Well, that's 8. So I'm evaluating, okay? So log base 3 of 27 equals, we're trying to find the answer. Well, the answer for this is cubed, right? 3. How do I know? Let me verify. 3, which is the base, to the exponent of 3, 3, which is the base, to the exponent of 3 will equal 27, okay? 4 to what power will give us 1 over 16th. In other words, log base 4 of 1/16th, well, it has to be a negative exponent, okay? So this will be -2. Let me verify it. 4 to the -2 power is 1 over 4 to the +2 power, which is 1 over 16. It's a +2, okay? So I'll let you keep on refreshing your mind with the verifying. And let's do a couple of using the laws or properties of logarithms. Okay, simplify. Well, there's 2 of them. I need to understand that this is in an expanded form. This is an expanded form, and I can evaluate when it's a single logarithm. Okay, we like the single logarithms because we can evaluate. So I'm going to have to use the laws or properties of logarithms to turn this into a single logarithm. The bases are the same, so I can say log base 2. I have a 6, I have a subtraction, and I have an x. So I have to remember that subtraction means division. So there you go. That's as far as I can go. I cannot solve any further because I don't know what x is. So this is our final simplification, okay? I have this 1/2 in front of the ln, which is the natural log of x. So the rule tells me I have to put that exponent back in here where it belongs. So ln of x to the 1/2 power. Or you can write ln of x, ln of the square root of x. They are both equivalent expressions. And I need to recognize that they both mean the same exact thing. If this was a multiple choice and I had to choose, I got to recognize that they are equivalent, okay? All right, I'll let you do number 7. You got to put that power back up here. You got to put that 3 back up here. And then you got to condense them all. Okay, so why don't you give it a try? This was covered in the previous objective and in class and in homework. Okay, all right. Let's go ahead and solve equations, logarithm equations, by using what we have learned so far. I'm going to introduce now the inverse property. Okay, we're going to need to use the inverse property so we can go ahead and solve logarithm equations. If I have a logarithm, let's just focus on this logarithm right here. I have a log base b of x. If I exponentiate, if I turn this logarithm into an exponent by using exactly the same base as it was in the logarithm, then that can reduce, they undo each other, and the answer will be x. Okay, so if I have a log base 2 of x equals whatever this is over here, let's call it y. I can exponentiate, I can make my logarithm become an exponent, but if I do it on the left, I have to do it on the right as well. Then that means that I can undo the logarithm, and that value over there, x, equals 2 to the y power, okay? So I can do what is called exponentiate, okay? Look at the example over here. If I have a log base 3, all I have to do is exponentiate by using a 3 here, okay? And then that will undo each other, and the answer will be 5, okay? That value up there has to equal each other, okay? So let's see if that makes sense as we use to solve the equations. When I look at number 8, I see that I have two logarithms, 2 logs. I have 2 logs. They're both the same base. I need to condense. So let's condense those 2 logs into a one single log by using the laws or properties of logarithms. So I can condense it into log base 3. And then I have an 8 plus an x. So an addition becomes multiplication of 8x equals 4. So at this point right here, all I did was I condensed. That's all I did. I didn't use anything else. I just used the laws or properties of the logarithm to condense. Now I'm ready to exponentiate both sides of this equation. I'm going to turn my logarithm into an exponent by using the base 3. But if I do it to the left, I better do it to the right. Okay, so the base log base 3 will undo with the base 3 here. And I'm going to have simply an 8x. And on this side, I have 3 to the 4th power. Some student says, well, you have log base 3 of 8x equals 4. Isn't it the same thing as just saying 3 to the 4th power equals 8x? 3 to the 4th power equals 8x. Yes, it is. Okay, see, it's still a true statement. So the law, the inverse property, keeps it a true statement. Okay, so now I can go ahead and continue to evaluate what is 3 to the 4th power. Let me go ahead and switch it back to red. 8x equals 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. Then I want to isolate because I want to solve the equation for x. Then what I'll do is I'll divide both sides by 8. And then x equals 81 over 8. Let's not turn into decimals. Let's just keep it as a fraction. It's improper, but that's okay. So did we follow the steps here? Did I simplify to a single log on each side of the equation as needed using the property of logarithm? Yes, that was my first step, was condensing. Did I exponentiate both sides of to eliminate the log? Yes, I did that right here, that step, right there, and that step right there, okay? Then I solved the remaining equation, okay? So that's what we did there. We followed these 3 steps. We always want to condense before we can exponentiate, okay? Let's try one more. Notice that I have 2 of the natural logs, and I have a subtraction. So I'm going to condense. Let me go ahead and write down condense. I'm going to have ln of x over a 2 equals a 4. So at this point, all I did was I simplified to a single logarithm. I condensed it. Remember that ln, okay, let me put a little note here. Remember, ln means log base e, the natural log, okay? So if I want to exponentiate, then I'm going to exponentiate both sides with the base of e on the left, e on the right. So now my equation became exponents. That's what exponentiate mean, is my equation became exponents. So the e in the natural log will undo itself. Okay, they undo each other. And I end up with simply x over 2 equals e to the 4th power. See, that 4th, that was an equation, became an exponent. Okay, now I want to solve for x, solve the remaining equation. So I want to get rid of this denominator. Whenever I want to get rid of the denominator, we multiply by a reciprocal on both sides. The 2 on the denominator tells me that it is 1/2. So I'm going to multiply by a 2 over 1 on the left and a 2 over 1 on the right. So on the left, it will undo each other. We'll have an x. And then here, instead of writing e to the 4th times 2, we're going to write 2 times e to the 4th. And that is an exact value, not a decimal. Just like this is an exact value, not a decimal. Okay. Now, if your teacher or a multiple choice asks for decimal, then I can go ahead and put that in my calculator. But we are not using calculator, so we leave it as an exact answer. Okay. All right. Let's go ahead and see if we can do some more examples to make sure we understand. I would like for you to pause the video for just a few seconds, okay, a minute maybe, and I want you to give it a try. Do you recognize what to do here first? Okay, so first thing I see is that I have only one logarithm, so I can't condense it. It says simplify to a single log on each side. I already have that. I already have a single log on each side. So why don't I use the other laws of logarithms? Okay, they have it right here in front of me, 1, 2, 3. Let me see if I remember what to do. Oh, I see a power that needs to go back. So why don't I put that power back in here? So this is going to become the ln of 9 to the 1/2 power equals the ln of 4x. Okay. Now I should remember that the exponent of 1/2 means square root. So the ln of the square root of 9 equals the ln of 4x. Well, I can take the square root of 9. We can evaluate what is the square root of 9? 3. So I can go back over here and say that this is equivalent to the ln of 3, which equals ln of 4x. Now let's turn this equation into an exponent. Let's exponentiate. Let's turn this into exponents. So I'm going to use, because it's an ln, we're going to use base e on the left, base e on the right. So the e and the ln will undo itself. I'm going to end up with a 3. The e and the ln will undo itself. I'm going to end up with a 4x. Okay. So I want to solve for x, solve the remaining equation. Therefore, I'm going to divide by 4 on both sides. So x equals 3/4, an exact value. There you go. Okay. So I would like for you to give it a try to number 11. I did this. You should try this because it's very similar. They are similar in nature. You got to put the powers on both sides, put the power back, and then see if you can solve it. Okay. I would like to go over this with you in class when we're together. All right, let me go ahead and do another challenging one. Let's go ahead and do number 12. And then I'll do another one and we'll be done, okay? Well, I'll do a few more. Okay, so notice over here that now I have 2 logs. I don't have just 1, I have 2. So I do need to condense. Totally different than the previous problem. I only had 1 log. I have 2, so I have to condense first. So this is going to become log base 4. I have an 8 plus a 2. So a plus is a multiplication. So it becomes a 8 times a 2 equal x. It becomes a multiplication. So let's go ahead and keep on simplifying because this becomes log base 4 of 16 equals x. Some of you immediately see that you can evaluate the left. You can say, I know the answer for this. 4 squared equals 16. You can go ahead and do that. You can go ahead and evaluate the left and keep the right as your variable, okay? So log base 4 of 16 is simply a 2. How do I know? We know that 4 squared equals 16, and this is the evaluation of a logarithm, okay? So you get a simple answer right away without doing much. Now, could I have exponentiated both sides? Yes, you could have. You could have exponentiated both sides and you still get the right answer, okay? All right, so let's go ahead and do the next one, number 13. All right, so I have log, I have a single log, one single log, so that means I don't need to condense, but I have to recognize that there is no base. So let me make a note here. Where's the base? Where is the base? Okay, where's the base? If there is no base, then we know it's invisible, and that is base 10. So I'm going to put it in nice little blue over here so you can remember when it's invisible is base 10. So I can exponentiate both sides immediately. Okay, I can exponentiate both sides immediately and say 10 becomes the base here and 10 becomes the base here. So 10 with the log of 10 will undo each other, and I end up with simply 3x minus 5 equals 10 to the 0. If you exponentiate on the left, you have to exponentiate on the right. Okay? So now I can evaluate 3x minus 5 equals, what is this answer here? 10 to the 0 power is simply 1. Okay. So now I can simply solve the remaining equation. I'm going to add the 5 to the right. I'm going to have 3x equals 6, and I'm going to divide by 3 on both sides. We're going to have that x equals 2. Okay? All right. One more, but I want to do something a little bit more difficult. I want you to try this one. Okay? You're going to condense. No, actually, I do need to do this one. Let's go ahead and let's condense first, because I do have 2 logs, not only one. So I'm going to condense into log base 2. I have an addition. I have my first term and my second term. So this becomes multiplication. X times x plus 7 equals 3. At this point, because I simply have one logarithm, I can go ahead and exponentiate. So I'm going to exponentiate. I'm going to turn my equation. Okay, I'm going to exponentiate both sides, which means I'm going to turn my equation into exponents. But I have to use the correct base, which is base 2. So 2 became the base, 2 is the base right there. So now my equation became the exponents. So the 2 and the log base 2 will undo itself. Okay, they will undo each other. And I'm going to have this expression of x times x plus 7 equals 2 cubed. Okay, we can go ahead and distribute this multiplication. It becomes x squared plus 7x equals an 8, because 2 cubed is equals an 8. And let's go ahead and use the zero product property and set this equal to 0. Let's subtract 8 to both sides. Let me continue over here. I'll have x squared plus 7x minus an 8 equals 0. And let's go ahead and factor it. We have that skills of factoring. Okay, it's going to become x plus 8 and x minus 1. When I multiply 8 and negative 1, I get a negative 8. But when I add them together, I get a positive 7. Now we set it equal to 0. So x plus 8 equals 0, x minus 1 equals 0, and we solve for x. X equals -8, and x equals +1. Now I have to decide which one of these are the correct value to put it over here. Well, let's just look at one of these logarithms. We don't even have to look at both, because if it fails in one, it should not even continue, right? When you have over here log base 2 of x, well, can the x be negative? Can I have log base 2 of -8? Ask yourself this question. Can that work? No. So it cannot be a -8. It has to be x equals 1. Okay? It cannot be a -8, so it has to be x equals 1. That's our only solution right here, is x equals 1. Okay. So I would like for you to try number 15. Okay, I'm going to get you started, and I would like for you to try. Number 15, I have one logarithm on the left, which is okay. I only have one logarithm here on the left, but on the right, I have 2 logs. Okay, on the right, I have 2 logs. I'm going to have to condense this side first. So let's condense the right side, not the left. Log base 5 of 2x minus 3 equals log base 5. It's a subtraction of 2 logarithms. It becomes 14 divided by 2. So log base 5 of 2x minus 3 equals log base 5. 14 divided by 2 is simply a 7. I would like for you to continue this. I would like for you to continue and solve for x, okay? I will also get started on this number 16. I have 2 logarithms on the right and only 1 logarithm on the left. So let's condense on the right, sorry, on the left. Let's condense on the left. On the right, we are good. So I have a subtraction and a ln. So we're going to condense into a ln of a subtraction, which means division. So I'm going to have the 2x plus 4 as my numerator because it came first. And I'll have the x minus 1 as my denominator because it came second. I'm going to exponentiate. I'm going to turn my equation into exponents. But since the ln, we're going to use base e. The e and the ln of e will undo, or the log base e will undo each other. And we're going to have 2x plus 4 all over x minus 1 equals the e will undo the ln and we'll get a 3. Every time we want to clear a denominator, that's what it's called. We want to clear, we want to get rid of this denominator. We multiply both sides by the exact denominator we want it cleared. So I'm going to multiply by x minus 1 on the left and x minus 1 on the right. On the left, we'll undo each other, okay, because they will undo each other, multiplying and dividing. And I'm going to end up with simply 2x plus 4 equals 3 times x minus 1. I'm going to distribute my multiplication, and I would like for you to continue to solve for x, okay? So I'd like for you to finish both of these, and we'll definitely go over in class if you have any questions, like Ms. Myers, what are the answer for number 15? What is the answer for number 16? What is the answer for number 11? Okay, so we can go over those. Please, if for by any chance I forget, please remind me, okay? And that is how you solve equations using the laws or properties of logarithms, okay? Good job. Talk to you later.